In this video, we're going to talk about equations quadratic in form. So let's solve the following equations. So this is a traditional quadratic equation, so we know we have to set it equal to 0. So I'll add the 12. So first off, is there a greatest common factor I can take out of the terms other than 1? Answer is no. It's a trinomial, so I want factors of 12 whose sum is negative 8. Well, that's negative 6 and negative 2. So break it down. How do I break down x squared? That's x times x minus 6 minus 2. Set each factor that contains a variable equal to 0. And we get x equal to 6 and x equal to 2. So the solution set for this would be 2 and 6. Okay, so how does this change if instead of it being x squared, it's x to the 4th? Well, first off, I'm going to set it equal to 0, just like before. Is there a greatest common factor I can take out of the terms other than 1? Answer is no. So we're back to factors of 12, whose sum is negative 8. Similarly as before, it's negative 6 and negative 2. Adding them up, that's negative 8. So now, what value times the same value gets me to x to the 4th? Well, that's x squared times x squared, and I'll use minus 6 and minus 2. Set each factor that contains a variable equal to 0. So I would add 6, take the square root of both sides, that's x equal to plus or minus the square root of 6. Here I would add 2. Take the square root, x is equal to plus or minus the square root of 2. So my solutions would be what? Negative square root of 6, negative square root of 2, square root of 2, and square root of 6. Okay, let's take a look at the next example. So here I'm taking the quantity x plus 3 squared plus 6 times a quantity x plus 3 plus 8. So again, I'm going to do it similarly to above. Factors of 8, whose sum is 6. That's going to be 4 and 2. 4 plus 2 is 6. Now, what value times the exact same value gets me to x plus 3, the quantity squared? That's x plus 3 times x plus 3. Now, I can put in then plus 4 and plus 2. Now, you might wonder, where do these 6 times the quantity x plus 3 go? Well, it's the outer plus the inner here. Okay. So it hasn't gone anywhere. So I'm going to simplify each set of parentheses. 3 plus 4, that is 7 for the first set of parentheses, and 3 plus 2 is 5. And then I can set each factor that contains a variable equal to 0. So here we have negative 7 and negative 5. So I can write out my solution set. Now, the 3 previous examples that we did, notice every single one of them has a leading coefficient of 1. Notice this problem has a leading coefficient of 2. So I will factor this a little bit differently because the leading coefficient is not 1. First off, is there a greatest common factor I can take out of the terms other than 1? Answer is no. So now what I will do is I will take the factors of 6 times 2, which is 12, whose sum is 7. Well, that's going to be 3 times 4 is 12, and of course 3 plus 4 is 7. So now, here's how I'm going to write this. So we'll do 2x to the 4th, but instead of 7x squared, I'm going to replace it with plus 3x squared plus 4x squared. Then I'll put the plus 6 is equal to 0. So now notice how many terms I have. I have 4 terms, so I'm going to do factor by grouping for this problem. So I'll group the first 2 terms together, and I'll group the last two terms together. Well, what can I factor out of the first 2 terms? That's an x squared. I'm left with 2x squared plus 3. What can I factor out of the last two terms? That's going to be a 2. That leaves me with 2x squared plus 3. Now, what's the greatest common factor out of the terms I just underlined? Well, notice the parentheses is exactly the same, so that's 2x squared plus 3. And then the factor that I'm left with is x squared plus 2. Now again, you can check your answer for all these problems by multiplying or foiling them to get back to the original. Okay, set each factor that contains a variable equal to 0. We'll start with the left, subtract the 3, divide by 2, and then we're going to take the square root. Now, keep in mind with this, I can separate them. I'll put the square root of negative 3 on the top, the square root of 2 on the bottom. Because there's a negative under the square root, I automatically know there's going to be an I coming out. And then I don't like having the radical in the denominator, so I'm going to multiply the top and the bottom by the square root of 2. So on the top, I have the square root of 6 times I, and on the bottom, remember the square root of 2 times the square root of 2 is 2. So I'll put the plus or minus. So 2 of my answers are going to be plus or minus the square root of 6, I all over 2. The other part, subtract the 2. Take the square root of both sides. That's x equal to plus or minus the square root of negative 2. Again, when I have a negative under the square root, the I comes outside the radical. So here I have plus or minus 2i. So my solution set, if I wanted to write all of them out, would be negative square root of 6i over 2, positive square root of 6i over 2, negative square root of 2i, and then positive square root of 2i. Okay, next example. So again, notice here we have a leading coefficient of 1 again, so this will be a little bit easier to factor. So again, we want factors of negative 12 whose sum, well, I don't see a number there, so if I don't see a number, what do I assume is there? That's a 1, so its sum is a positive 1. So that would be 4 times negative 3 is negative 12, but when I add those two numbers, that's 1. Now, how do I break down x to the 2/5? What two values multiply to give me x to the 2/5? That's x to the 1/5 and x to the 1/5. So plus 4 and minus 3. Set each factor that contains a variable equal to 0. So here I would subtract the 4, and then I will take both to the 5th power, so that would be x is equal to negative 4 to the 5th, which is negative 1,024. Here I would add 3, take the 5th power to both sides, that would be x to equal to 3 to the 5th, and that's equal to 243. Okay, last example we're going to take a look at. So is there a least greatest common factor I can take out of these terms other than 1? Well, the answer is no, but here the leading coefficient is not a 1, so we're going to have to do a little bit more work. So it's going to be factors of negative 10 whose sum is negative 9. Well, that's going to be negative 10 times 1 is negative 10, but when I add them, that's going to be negative 9. So rewrite the first term. I'm going to replace negative 9x to the 1/3 with minus 10x to the 1/3 plus x to the 1/3, using those. Don't forget the minus 2 and set it equal to 0. So now I have 4 terms. So I'm going to go back to factor by grouping. So what can I take out of the first 2 terms? Certainly a 5, and I can take x to the 1/3. Remember, when I divide, I subtract the powers. So x to the 2/3 divided by x to the 1/3 is x to the 1/3. 10 divided by 5 is 2. Remember, I can always factor out a 1, so it'll be a plus 1 here. and it's still going to be x to the 1/3 minus 2, and of course set equal to 0. Take a look at these two terms. What do they have in common? Again, it's what's inside the parentheses, so that's x to the 1/3 minus 2, and the other factor is 5x to the 3rd plus 1, and of course set equal to 0. So set each factor that contains a variable equal to 0. So add 2, and then here I will cube both sides. That's x equal to 2 to the 3rd power. That's x equal to 8. Here I'll subtract the 1, divide by 5, and then I'll take this, each side to the 3rd power. Well, we'll put this over here. Negative 1/5 times negative 1/5 times negative 1/5. So certainly it's a 1. 5 times 5 times 5 is 125. So my solution set would be 8 and negative 1 over 125.